Please like, share and subscribe my YouTube channel, YT Abdul Aleem.
Friends, I hope you're all doing well. In this video, I'll explain what a counter is and the different types of counters. So let's get started. Types of numbers used in PLC. Natural numbers. Natural numbers. The basic counting numbers, 1, 2, 3, 4. Note, some definitions include 0, while others start from 1. Whole numbers. Natural numbers plus 0, 0, 1, 2, 3. Integers. All whole numbers and their negatives, 3, 2, 1, 0, 1, 2, 3. Rational numbers. Numbers that can be expressed as fractions of integers, 1/2, 3/4, 5, 0.75. Real numbers. All rational and irrational numbers combined, 3, 0.5 square root 2, pi. Complex numbers. Numbers of the form a plus b, where a and b are real numbers, and I is the imaginary unit, square root, 1. Special categories of numbers. Odd numbers. Integers not divisible by 2, 1, 3, 5, 7. Even numbers. Integers divisible by 2, 0, 2, 4, 6. Prime numbers. Natural numbers greater than 1 that have no divisors other than 1 and themselves, 2, 3, 5, 7. Composite numbers. Natural numbers greater than 1 that are not prime, they have divisors other than 1 and themselves, 4, 6, 8, 9. Perfect numbers. Positive integers equal to the sum of their proper divisors, 6, 28, 496. Transcendental numbers. Irrational numbers that are not roots of any non-zero polynomial equation with rational coefficients, pi, e. Numbers. In PLC programming, several number types are commonly used to represent data. These include binary, integers, and real numbers, along with Boolean, BCD, and other specialized types. These data types are crucial for accurately storing and manipulating numerical values within a PLC's program. In this pictures you can see different types of numbers. Decimal system. The decimal system, which is most common to us, has a base of 10. The radix or base of a number system determines the total number of different symbols or digits used by that system. For instance, in the decimal system, 10 unique numbers or digits, i.e., the digits 0 through 9, are used. The total number of symbols is the same as the base, and the symbol with the largest value is 1 less than the base. In this pictures you can see decimal system. Binary system. The binary system uses the number 2 as the base. The only allowable digits are 0 and 1. With digital circuits it is easy to distinguish between two voltage levels, i.e., plus 5V and 0V, which can be related to the binary digits 1 and 0. Therefore, the binary system can be applied quite easily to PLCs and computer systems. In this pictures you can see binary system. Negative numbers. If a decimal number is positive, it has a plus sign. If a number is negative, it has a minus sign. In binary number systems, such as used in a PLC, it is not possible to use positive and negative symbols to represent the polarity of a number. One method of representing a binary number as either a positive or negative value is to use an extra digit, or sign bit, at the MSB side of the number. In the sign bit position, a 0 indicates that the number is positive, and a 1 indicates a negative number. In this pictures you can see negative numbers. Octal system. To express the number in the binary system requires many more digits than in the decimal system. Too many binary digits can become cumbersome to read or write. To solve this problem, other related numbering systems are used. In this pictures you can see octal system. The octal numbering system, a base 8 system, is used because 8 data bits make up a byte of information that can be addressed. Octal is a convenient means of handling large binary numbers. In this pictures you can see binary to octal system. Hexadecimal system. The hexadecimal, hex, numbering system is used in programmable controllers because a word of data consists of 16 data bits, or two 8-bit bytes. The hexadecimal system is a base 16 system, with A to F used to represent decimal numbers 10 to 15. In this pictures you can see hexadecimal system. Binary coded decimal, BCD, system. The binary coded decimal, BCD, system provides a convenient way of handling large numbers that need to be input to or output from a PLC. As you can see from looking at the various number systems, there is no easy way to go from binary to decimal and back. In this pictures you can binary coded decimal, BCD, system. The BCD system provides a means of converting a code readily handled by humans, decimal, to a code readily handled by the equipment, binary. In this pictures you can binary coded decimal, BCD, system.
Thanks for watching.